The Voith Schneider Propeller, also known as a cycloidal drive, is a specialized marine propulsion system. It is highly maneuverable, being able to change the direction of its thrust almost instantaneously. It is widely used on tugs and ferries. Operation: from a circular plate, rotating around a vertical axis, a circular array of vertical blades protrude out of the bottom of the ship. Each blade can rotate itself around a vertical axis. The internal gear changes the angle of attack of the blades in sync with the rotation of the plate, so that each blade can provide thrust in any direction, very similar to the collective and cyclic of helicopter flight controls. Unlike the Azimuth Thruster, the Voith Schneider drive merely requires changing the pattern of orientation of the vertical blades. In a marine situation, this provides for a drive which can be directed in any direction and thus does away with the need for a rudder. It is highly efficient and provides for an almost instantaneous change of direction. These drives are becoming increasingly common in workboats such as fireboats and tugboats where extreme maneuverability is needed. Azimuth thrusters have both advantages and disadvantages when compared to cycloidal drives. The azimuth thruster is less efficient and slower to maneuver, but is likely to be cheaper in the short term. Life cycle costs favor the Voith solution, something reflected in the residual value of a Voith water tractor. A choice is made on the basis of perceived performance requirements. Instead of a quart nozzle, VSPs are often fitted with a thrust plate, or propeller guard, which acts as a nozzle at low speed, protects the VSP against grounding and provides another blocking location during dry docking. A low acoustic signature favors the device's use in minesweepers by minimizing cavitation as the rotor does not need to rotate as fast for a given thrust. The underwater sound signature of the MV North Sea Giant dynamic positioning vessel was measured by the International Centre for Island Technology whilst installing a foundation monopile for the Voith tidal energy device in the Falls of Warness, Orkney. VSPs are offered with an input power range of 160 kW to 3900 kW. History: the Voith Schneider Propeller was originally a design for a hydroelectric turbine. Its Austrian inventor, Ernst Schneider, had a chance meeting on a train with an employee of Voith's subsidiary St. Par Paragraph Lten Works. This led to the turbine being investigated by Voith's engineers, who discovered that although it was no more efficient than other water turbines, Schneider's design worked well as a pump by reversing the flow through the device. By changing the orientation of the vertical blades, it could be made to function as a combined propeller and rudder. In 1928 a prototype was installed in a 60-horsepower motor launch named Torqueo and trials were carried out on Lake Constance. A number of German minesweepers were fitted with VSPs. The first of these was the R8, built in 1929 by La 1/4 RSSEN. By 1931 VSPs were being fitted in new vessels on Lake Constance run by the German state railways. The first such ship to use the Voith Schneider Propeller was the Excursion Boat Kemp 10. Two German 1935 Type M-class minesweepers M1 and M2 were fitted with VSPs. The first British ship to use Voith Schneider propellers was the double-ended Isle of Wight ferry MV Lymington, launched in 1938. Some 80 ships had been installed with VSPs by the end of the 1930s, including the uncompleted 1938 German aircraft carrier Graf Zeppelin, and the Japanese submarine cable-laying ship Toyo Maru. The three vessels currently used by the Woolwich ferry feature Voith Schneider propulsion systems. They were built in 1963 by the Caledon Shipbuilding and Engineering Company of Dundee and feature one VSP in the bow and a second in the stern for remarkable maneuverability. The U.S. Navy built 12 VSP-equipped Osprey-class coastal minnow hunters in the 1990s. These vessels have been decommissioned and are being sold to foreign navies. The French Navy operates 16 tugboats of the RPC-12 type, that can provide a 12-ton bollard pull thanks to two Voith Schneider propellers. The same device, mounted on a horizontal rather than a vertical axis, has been used to provide lift and propulsion on a few experimental aeroplanes, known as cyclogyros. None of them were very successful. See also, Azipod, Azimuth Thruster, Dynamic Positioning, Cycloid, HMS Challenger. References: Brown, R. Allen. Lymington, The Sound of Success, Allen T. Condy Publications. ISBN 978-0-907742-62-3. External links: Voith Turbo Marine website, Seagoing Egg Beaters Popular Mechanics, March 1950, pages 102 to 103. Download of PC application IVSP.